6 months ago, I dug a massive hole in our backyard and I actually found water. But then I got the water quality results and it wasn't good. Go drink the water! In this video, we're gonna test 3 popular methods for treating shallow wells. And then we're gonna decide which one is best for our family. Courtney, our water results are in. Go drink the water! I think we have a problem. So our shallow well water has tested positive for both coliform bacteria as well as E. coli. Coliform and E. coli aren't necessarily dangerous for us to ingest, but they are a really good indicator that there could be much more serious bacteria living in that water. And those bacteria can cause things such as giardia, typhoid fever, dysentery, and hepatitis. And that's scary. These bacteria can be found in any well, but they're a lot more common in a shallow well that's a lot closer to the surface where these bacteria exist from animal feces and human feces. I have not been pooping back there, but I've seen a lot of deer, and our friend Mr. Squirrel, he likes to poop back there. Luckily, there are things that we can do to treat the water that theoretically make it safe for consumption. Let's find out. Today we're gonna be treating the water using 3 popular disinfection methods: bleach, ozone, and UV light. We're gonna try to see which of these work and maybe which of them don't. I've got buckets and a pump. Let's go collect some water samples. If you stay on this little rock zone, then you don't sink into the mud as bad. Look at the way the water just bubbles up from underground.
Where's your hand going?
I don't know. All right, what do we have going on inside? Oh. So the water level is still above the ground level. That's crazy. If you're new to the channel, this is the shallow well I dug last summer. If you haven't seen that video, I recommend going back and checking it out. The short version of the story is that we live on a hill where we were told there was no water. And I'm pretty sure that I found water at just 12 feet deep right here next to the shop. During this time of the year, I think we could fill basically an infinite amount of storage capacity. Like we could have giant storage tanks here. But in order to do that, we need to figure out a way to treat this water so that we can actually use it. I think the next step is to collect 4 water samples. Courtney and I met over 11 years ago, and we've gone through a lot of life changes together. Starting a business, living in tiny spaces together, and now raising our son Oliver. There have been a lot of challenges over those 11 years, and we didn't always know how to handle them. As our lives got more complicated and we weren't carefree teenagers anymore, we both felt like we needed help communicating better. 4 years ago, we started going to therapy, and now I feel like I have this toolbox full of tools that I didn't even know existed. I'm a better listener, and I'm able to communicate my needs way more effectively. It has allowed me to strengthen relationships with friends, family, and colleagues, and be more supportive of Courtney during our first year of parenthood. Seeing a therapist in person can be difficult with our busy schedule, and that's why for almost 2 years now, we've been using BetterHelp. And with that, I'd like to thank BetterHelp for sponsoring this video. BetterHelp connects you with a licensed therapist who's trained to listen and give you helpful advice. Getting started might feel like the hardest part, but it doesn't have to be. Simply go to betterhelp.com/ambitionstrikes and answer a few questions about yourself. You'll be matched to a therapist usually within 48 hours, and you can start communicating by phone call, video chat, or messaging. It's about what works best for you. I've even done a session while sitting in our excavator. To add a few more tools to your personal toolbox and get a special discount on your first month, head to betterhelp.com/ambitionstrikes or click on the link in the description below. And thanks again to BetterHelp for sponsoring this video. Whoa! Avoid the sinkholes. So this pump has a float switch. When the water level rises, it'll turn the pump on. When the water level drops, it turns the pump off. So as soon as I drop this into that, it's going to start pumping, and we're gonna let it pump until we reach the static water level. I'm also gonna tie this though. That's not going anywhere. I want the hose like over there. Now we're gonna lower the pump, hopefully all the way down to the bottom. Okay, it's on. We're pumping water. The water is really clear. I was really surprised when I took that other sample to send off to the lab. Clunk. Okay, we're at the bottom. Pump is sitting on the bottom. Now we're just gonna let the pump keep pumping until we hit the static water level, which is the level at which the water coming back into the well reaches the rate that it's pumping it out of the well. So our water level is going to drop to a point and then stop dropping, and that's where we're gonna take our water test sample water from. It's a lot of water. And look, like the water level's not dropping now. It's right there. There's 9 feet of water on top of that pump, and it just fills as fast as it pumps it back out again. So this is filling up that fast, just from the ground from here. Well, should we fill some buckets? Courtney, I'm gonna apologize in advance if I accidentally completely spray you with the hose, with poo water, because this water literally tested positive for poo. It looks so clean. That one's got some floaters in it.
Gold.
Yeah? To the shop. Or I guess now it's to the science lab. Hi, Boone. Hi, Bailey. Have a nice walk. Today we're going to be testing 3 of the most popular rainwater off-grid home water treatment methods, which are chlorine, ozone, and UV light. I think there are advantages and disadvantages to all of them, but let's start with the easiest and the cheapest one, which is chlorine. There are lots of ways to chlorinate water. In this test, we're going to be using regular old household bleach. The CDC's website has a pretty good chart on different concentrations of household bleach and how much of it to add to what amount of water. We're going to be adding just a 1/4 teaspoon of bleach to this water, going for 4 parts per million of bleach to water. This is not very much bleach. Let's see. Woo! Good thing I'm wearing my Sunday best right now. Into the water. This smells terrible. Don't get it on anything I care about. Rinse it down the sink. We were trying to find something that was like non-porous and able to be sanitized to do this test, and we're using a garden stake. Very scientific. This is one of the first downsides of bleach, which is that for it to be effective, it needs to be mixed. And that's really, really difficult to do in a water environment with storage tanks and pumps and hoses. And now we're supposed to let this sit for a minimum of 10 minutes of contact time of free chlorine in the water. That's the second issue here, is the free chlorine part. There are 2 types of chlorine in the water. There's what's called total chlorine and free chlorine. Based on the amount of organic materials or volatile compounds that are in here, that chlorine is highly reactive, it's an oxidizer, and it wants to stick to those things, which reduces the amount of free chlorine that's in the water, which is the amount of chlorine that's available in the water to kill bacteria. So we're going to be using these test strips to try to see just how much free chlorine is in this water now and 10 minutes from now, because we may need to add more chlorine to this water to make sure that we have 10 minutes of contact time with free chlorine. So here we go. And actually right now, our chlorine levels are very high. I'm surprised, but let's wait 10 minutes and see what happens then. While we wait for the chlorine to do its thing, let's go get the ozone started. And to do this, we're heading outside. Here we go into the dog run, because that's where we store the ozone. This is the buried cistern that we installed last summer, and inside of here we have an ozone generator. This tank holds potable water that we had delivered before the winter started, and right now we're at about 2/3 full. Do you see it making bubbles? That's crazy looking. Ozone's molecule is O3, like 3 oxygens, and it is super, super, super unstable. It wants to split off into O and oxygen, O2, and that extra O gets attached to other molecules and breaks them down. And in the process of that, it breaks down cell walls of viruses and bacteria. It can break down contaminants. It can oxidize volatile compounds. It's a really powerful water disinfectant. The problem is that we have no idea how much of it ends up in our water. The amount of ozone that this generator produces is dependent upon temperature and humidity, so we don't really have a good idea of how much ozone it's making. We also have no idea how much of that ozone the water is absorbing. So basically the way that I think I understand this is the longer we can have our water in contact with ozone, the better. So by having it installed in this tank where this water has literally been in contact with ozone now for months, that increases our chances of it being an effective disinfectant. So for this test, we're putting an extremely high concentration of ozone into this bucket because this bubbler is intended to be installed in a 5,000 gallon tank. 10 to 20 minutes should be plenty of time to kill whatever might be in that bucket. But we'll see. Let's go check back in on the chlorine. Okay, 10 minutes later, let's give this thing a stir and see where we're at. They're actually still just as high. which I'm surprised by. It's a good thing because it means that we have plenty of free chlorine in this water to kill whatever bacteria might be in there, but it's a bad thing because the CDC lists 4 parts per million as the maximum threshold for drinking water. So our water is now way over chlorinated and not safe to drink. Even though we only added a 1/4 teaspoon, which was based on the calculator that we used and was supposed to be the appropriate amount of chlorine to add to this amount of water to get to 4 parts per million. While we wait for our ozone to go, now we're gonna move on to the UV, which is the most instantaneous disinfection method. This is a UV water disinfection system. So the way this works is there's a UV bulb inside here. UV is ultraviolet light. The ultraviolet light, just like the chlorine and just like the ozone, is a strong oxidizer that can break down the organic chemicals and the cell walls of virus and bacteria, which renders them harmless to us. One of the challenges with UV disinfection is that the water has to be clear, because otherwise what might happen is as the water flows through here, any particles or sediment in the water might shadow the light from ever reaching the pathogens or bacteria or virus or whatever it is that we're trying to kill. We've got a 2-stage filter and then a UV light. We just got this, so now let's get it set up. We slide this into this, and that basically makes a waterproof tube thingy that the UV light can then slide into. Water travels through this and around this. Gosh, this seems like I'm just gonna break this instantly. Screw it into place. See the little metallic balls inside there on the glass? That's mercury that's gonna get vaporized when it energizes. Unlike chlorine or ozone, as soon as the water leaves this disinfection chamber, it no longer has any disinfecting qualities, and if there's contamination downstream, well, the water's contaminated. So we're gonna disinfect this bucket to ensure we don't have any contamination. And then just to make sure that this Lysol doesn't affect our thing, we'll probably want to fill this bucket up, dump it out, and then fill it up again. I am so afraid to step over there. Yeah. This is something else. Oh! I'm the mud monster. I'm gonna turn the pump on. Oh. Okay, water's coming out on the other end. When I plug this in, it says it's gonna beep 3 times. Bam, and it has a green light to say lamp is on, so we know the lamp's good. This UV light is rated for 10 gallons per minute. It's important to get a UV lamp that's sized large enough for the volume of flow that we're expecting to have, because say this were only rated for 2 gallons a minute, but we're drawing 10 out of it, well, now we're not getting enough UV exposure time. The water's not in this chamber long enough to get exposed to UV light for enough time to actually do its disinfecting qualities. So we upsized the lamp to what I thought would be the most maximum water flow we'd ever see. Well, let's rinse our bucket out. And now we're filling up the bucket with what is theoretically clean, drinkable water. This system brings clean, drinkable water from poo to you, in theory. Oh, if you look right here, you can see a little bit of blue light coming out.
It just splashed in my mouth, so hopefully.
Did it taste good? Oh, here, hold on.
No, don't do it, Riley. Riley! You don't know that that's safe to do yet.
Trust the science. Oh, it tastes good though. Let's go test some water. Whoa. Have you looked in these yet? That is crazy. I don't know if you can tell, there's little oil droplets or like some kind of organic compound. Like it could be, who knows, tree sap, oil, something. There's something floating on top of the surface of these ones. But this one doesn't have that at all. This one just has little bubbles and a dog hair. So for this test, we're not doing a complete panel test on all of these because these disinfection methods are targeted towards getting rid of those potentially harmful bacteria. So we're only going to be testing for the existence of coliform bacteria. The full panel involves taking a sample, sending it off to the lab and waiting a week for the results. And so for this test, we're gonna be using these at-home kits that we found at our local hardware store that take 48 hours. Okay, here we go. This is the bacteria tester. Dip our little tube into our water. You ready? Okay, control sample. Now it says shake it for 20 seconds. I'm doing my shaky dance. It's gonna start purple, and then if at any point in the next 48 hours it turns yellow, that means there's coliform bacteria in this water. Control done. Now we need to test the rest of them. No cheating, and drop it in the comments below. Do you think there's gonna be coliform bacteria in any of our 3 disinfection methods? We'll see it in 48 hours. Okay, it's been 48 hours and we're about to find out together. Whoa! Well, our control has coliform, which is as expected because last week when I sent it off to the lab, it had coliform in it. But what's really interesting is that all 3 disinfection methods worked. The chlorine, the ozone, and the UV, none of those samples have coliform in them. Knowing what we know now, how are we going to treat our water? Well, we're actually going to use all 3 methods. We're going to create a 2-stage treatment plan with a 3rd stage as needed. Stage 1 will happen in our underground holding tank. As water is pumped out of our shallow well, it will be directed into the holding tank, where it will be treated constantly with ozone. This won't perfectly clean the water, but it should stop it from continuing to grow bacteria. That water can then be used all around the property for things like irrigation and washing the equipment. Stage 2 of our plan will happen when the water enters our home. It'll pass through the sediment filter and UV light combo that you saw us test earlier. This will ensure that any water that comes out of the kitchen faucet, the shower, the sinks will be completely safe to consume. And the 3rd part of our system, the backup fail-safe, is chlorine. I plan to test our water on a regular schedule. If I find anything concerning, I know that I can go treat the tank and then run that chlorinated water through our entire system. The reason that chlorine isn't going to be a part of our everyday system is that we don't want to consume it. As you've seen in this test, it's very difficult to get a consistent level of chlorine and very easy to overchlorinate. But it is extremely effective and very inexpensive. And with that, it's time to get our filter system with the UV lamp installed. For the P-trap, oh, did you know it was leaking? There it goes. Bombs away. Yeah. Pants keep falling down. I have a belt. What I need is wider hips. I knew when I did all the plumbing in the shop that eventually we were going to want to put some kind of whole house filter system here. So I put this loop in. Basically the water comes from our cistern over to here and then it loops back to everything else, making it really simple to put a filter system right here. This valve here turns off our supply coming from our cistern, and then this drains our house. I literally added this valve in for this exact scenario. Man, that must be what it means to be 30. Well, that I think about future me more. Now we got something solid to attach to. Oh, can you hand me a 3/4 inch crimp ring so I don't end up having to take this whole thing apart again? Just one. Thank you. I'll just slip this on here right now. Back off the bottom, dang it. Ow. Okay, I think that's good enough. It's probably not going anywhere. Go turn the pump off.
How do I turn the pump off?
You turn the breakers off. Can you give me a bucket, Karen? That was so dumb. I cut over here because I was like, oh, if I put the valve over here, I'll have more room to get around that. And I didn't even think about the fact that I was cutting on the pressurized side of the valve. Sorry and thank you. Now that the drama's out of the way, maybe. Don't you shake your head at me. This is a flow meter. It's got like a little propeller inside of it that spins when the water goes through it. It attaches to this screen so we'll have an idea of how many gallons of water have gone through those filters so that we know when it's time to change the filters. I'm gonna put this right here because then I don't have to put a coupling in.
Should we turn the water on? Is it gonna leak? What do you think?
Did you say, yeah, it's gonna leak, Ollie? I'm gonna run outside and turn the power on. You're gonna yell if it starts spraying water.
Okay.
So far, so good?
So far, so good.
Okay, I'm gonna turn the water on to the filters and I hope they don't leak. What on earth? There we go. There just has to be enough pressure We're purging the air out of the system, and that is a lot of flow that can go through these filters. So let's plug this in, which is gonna turn the UV light on, and lamp is on. Now that should let us know when it's time to change filters. And just like that, we're going from basically pond water to filtered water that we can drink. With our whole house filter installed, we are one step closer to using our shallow well water in our home. Next up this spring will be a permanent pump, a settling tank, and some underground plumbing. Drop it in the comments below. I'm curious to hear, how would you treat our shallow well water? Thanks for watching, and we'll see you next time.